which of the following intervals is the function f given by strictly decreasing? Again same problem, you have to check where this function in which interval f dash coming less than 0. Okay, three intervals are given: 0 to 1, pi by 2 to pi, and 0 to pi by 2. Okay, 0 to pi by 2. Let's do this. Given fx equals to x to the power 100 plus sin x minus 1. Okay, differentiate with respect to x. First time differentiating with respect to x. F dash x power 100, they were first one powerless. Hundred x to the power 99. Sin x derivative किधर? Cos x. Sit. Derivative of 1, 0. Now f dash 100 x power 99 plus cos x in open interval 0 to 1. Cos x greater than 0 always, because graph of cos x is like this. Cos 0 is 1, cos 0 is 1 here. This is the graph of cos x. This. So 0 to 1 means somewhat here. Graph is above the x-axis. In 0 to 1, cos x is positive. Cos x is positive, and also 100 x to the power 99 is also positive. Both are positive. If both are positive, so sum of positive is positive. It implies f dash x is greater than 0. F dash x greater than 0, it means in interval 0, 1, this function is strictly increasing, but we are looking for decreasing. So first is not what we are looking for. It implies fx is strictly increasing in 0 to 1. Okay, now we'll check for option B part. B part, interval pi by 2 comma pi. In pi by 2 comma pi. Pi by 2 comma pi means, if you see, this will be pi by 2 here and pi here. So this is like open is there, na? So this is second quadrant. In the second quadrant, cos is negative. Cos is negative. Cos x less than 0. But cos x minimum value is -1, maximum value is +1. Okay, and this remaining 100 x power 99, this is positive, and 100 x to the power 99 is positive. But 100 x power 99 is very large number, -1, again positive coming. So total combining is positive. Also 100 x power 99 is greater than cos x. Okay, greater than cos x in this interval pi by 2 comma pi. So f dash x positive. It implies fx is strictly increasing. In 0 to pi by 2. 0 to pi by 2, this is first quadrant. First, 0 to pi by 2. This is 0, this is pi by 2. In first quadrant, cos positive. In first quadrant, cos x positive. Cos x positive, and where is it? 100 x power 99 also positive, and 100 x power 99 is also positive. It implies sum is also positive. Sum positive, and sum is f dash x positive. So it implies fx is strictly increasing in 0 to pi by 2. 14. Find the least value. Least means minimum value. Minimum. Minimum value of a such that the function given by fx equals to x square plus ax plus 1 is strictly increasing on interval 1 comma 2. Strictly increasing. Strictly increasing symbol means f dash should be greater than 0. F dash, it means f dash is required. F dash is required. Fx x square plus ax plus 1, differentiating with respect to x, f dash x square derivative 2x, then a, because a constant, x derivative 1 plus 1 derivative 0. So f dash x value is 2x plus a. 2x plus a. And you know that for strictly increasing, f dash should be greater than 0. Okay. For strictly increasing on 1 to 2, f dash x must be greater than 0. F dash value is 2x plus a. 2x plus a must be greater than 0. So from here, 2x must be greater than minus a, and x must be greater than minus a by 2. X greater than minus a by 2. And we want a minimum value. Minimum value we will get exactly at 1. So minimum value of f, minimum value of f such that f dash x greater than 0 is at x equals to 1. At x equals to 1 means this value. So minus a by 2 equals to 1. So what is a? A will be minus 2. So minimum value of a is minus 2. 15. Let I be an any disjoint interval disjoint from minus 1 to 1. Prove that function given by it should be plus x plus 1 by x is strictly increasing on I. Let's do this. Okay. Write given function fx is x plus 1 by x. Okay. Differentiating with respect to x. F dash x. Now tell derivative. Who will tell? Kedar. 1. Next. 1 upon x. D by dx of 1 upon x. 1 upon x means x power minus 1. Actually, formula already given. Power first, 1 power less. Minus x square. It means minus 1 upon x square. 1 upon x direct formula is minus 1 upon x square. Okay, if not, then write the formula. Derivative of 1 upon x minus 1 upon x square. Now, put f dash equals to 0. Find critical points. Okay. Put f dash x equals to 0. F dash x means 1 minus 1 upon x square equals to 0. Okay. Then from here 1 upon x square equals to 1. It implies x square equals to 1, and x means plus minus 1. So there are two critical points, minus 1 and plus 1. Minus 1 and plus 1, we can again go by the same process, number line. This is the number line. On the number line, so these points, minus 1 here, plus 1 here. Okay, so this now number line now divided into three disjoint intervals. Three disjoint intervals. One is minus infinity to minus 1, and one is 1 to plus 1. One is 1 to infinity. Okay. Number line is divided into three disjoint intervals. Three disjoint intervals. Minus infinity comma minus 1, 1 comma minus 1 comma plus 1, and 1 comma infinity. And we want to prove this function is strictly increasing on I. I means those intervals which are disjoint from minus 1 comma 1. It means minus 1 comma 1 here, okay. Minus 1 comma 1 this interval. It means we have to prove this function is strictly increasing only in this interval and in this interval, okay, and in this interval. So strictly increasing means f dash should be greater than 0, okay, f dash should be greater than 0, okay. Now see sign convention. What is the sign here? Sign of f dash. This interval greater than 1. When you put any value greater than 1 in f dash, for example, greater than 1, suppose put 2. When you put 2, what you will get here? Then f dash value, suppose if you putting 2 value, f dash 2, then 1 minus 1 upon 2 square, 1 minus 1 upon 4, positive coming, 3 by 4, positive. So this is plus. Between minus 1 to 1 sign, select any number between minus 1 to 1. 0 is there, but 0 is not defined now because 1 upon x square, x cannot be 0. Other than 0, any number is allowed. 0.1 if you put, then 1 minus 1 upon 0.1 whole square, it will be 1 minus 1 upon 0.1 whole square is 0.01. Now decimal remove, then 2 0 increase here. So it will be 1 minus 100, okay, minus negative coming, negative, then it will be negative, okay. So this is negative, okay. Here 0 is deleted, okay, 0 is deleted, this 0 is deleted in this interval, and this sign will be again positive. You can select any number less than minus 1, minus 2 whole square plus 4, again 3 by 4. So we can see that f dash x is less than 0 in minus 1 comma 1 minus 0, okay. Also f dash x greater than 0 in minus infinity comma minus 1 union 1 comma infinity. Hence proved, because these two intervals are disjoint from minus 1 to 1. Hence our function is strictly increasing on I. So fx is strictly increasing on I, okay, on I, and I is what? I is what? Disjoint intervals from minus 1 to 1. No. 16. Prove that the function f given by log sin x is strictly increasing. Strictly increasing means f dash greater than 0 on 0 to pi by 2 and strictly decreasing. It means f dash less than 0 on pi by 2 comma pi. Okay, so first derivative, after that we will check in the interval sine of f dash. What is given? Fx value is log sin x. Differentiate with respect to x. F dash x. Uh, Derivative of log sin x. Log something 1 by something. And sin x derivative again dy dx of sin x. So it is cos x. Cos x upon sin x. Means cot x. F dash x is cot x. Okay. Now check in the interval. First interval 0 to pi by 2. Okay. In 0 to pi by 2. Okay. And 0 to pi by 2 is the first quadrant. You can see 0, pi by 2, pi, 3 pi by 2. 0 to pi by 2 open interval means it is the first quadrant. In the first quadrant, every trigonometric function positive. So obviously in 0 to pi by 2, cot x is greater than 0. And cot x means f dash x. So from here, f dash x greater than 0. F dash x greater than 0, it means function strictly is improved. It implies fx is strictly increasing, okay, on 0 to pi by 2. Okay, now check in the other interval. Another interval pi by 2 comma pi. Okay, in pi by 2 comma pi, pi by 2 comma pi, you can see which quadrant this is. Pi by 2 comma pi. Which quadrant? Huh? Second quadrant, no? Pi by 2, to pi. This quadrant. This is called second quadrant. And the second quadrant cot negative. Everybody knows. Okay, cot negative in pi by 2 comma pi. It is second quadrant. Okay, you can write also so that you should not forget. Second quadrant. So cot x less than 0 and cot x value is f dash x less than 0. F dash x less than 0, immediately function is strictly decreasing. It implies fx is strictly decreasing. Okay, on pi by 2 comma pi. Okay, prove. Okay, noted. It is same as previous question. To get the function log x is strictly decreasing on 0 to pi by 2 and strictly increasing on pi by 2, 3 pi by 2 to 2 pi. How the? Now correct? Okay. Fx log cos x differentiating with respect to x. F dash x log something 1 by something, something means cos x, and cos x derivative once again dy dx cos x. Cos x derivative minus sin x upon cos x. It means f dash value is minus 10x. Okay, minus 10x. Now we have to check minus 10x first quadrant 0 to pi by 2. Okay, now in 0 to pi by 2, this is first quadrant, correct? This is what? First quadrant. And first quadrant all trigonometric functions positive. So 10x is a trigonometric function. It implies we can write 10x positive means greater than 0. But here we have minus 10x. So 10x positive, it implies minus 10x negative. Okay, it implies minus 10x less than 0, and minus 10x value is f dash. It implies f dash less than 0, and it implies fx is strictly decreasing. Okay, decreasing on 0 to pi by 2. Okay, now solve another one. Also, this interval 3 pi by 2 to pi, 3 pi by 2 to 2 pi, this is a fourth quadrant, correct? No, in 3 pi by 2 to 2 pi. Also we know this means this is the fourth quadrant. Okay, fourth quadrant, and in the fourth quadrant 10 is negative. In the fourth quadrant 10x is negative. So but we want minus 10x, multiply by minus. Once you multiply by minus, inequality reversed. So minus 10x, this less than becomes greater than 0, and it implies f dash x greater than 0. It implies fx is strictly increasing on 3 pi by 2 to pi by 2. 2 pi. Done. 18 is proof that the function given by fx x cube minus 3x square plus 3x minus 100 is increasing in R. Okay, increasing in R, complete real line. R means complete real line. Right? Given function, solution fx equals to x power 3 minus 3x square plus 3x minus 100, and we want to prove that this function is increasing in R. Okay, increasing in R means we have to prove f dash x greater than 0 in R. We have to prove this. F dash means derivative, so differentiate this function, differentiating with respect to x. F dash x equals to x cube derivative 3x square minus 3x square, 3 as it is, x square derivative 2x, 3 as it is, x is 1, constant 0. So, and you can see 3 is common, 3 is common. If 3 is common, then remaining x square minus 2x plus 1. Okay, x square minus 2x plus 1, and this is formula x minus 1 whole square. 3, this is what, x minus 1 whole square, and whole square is always non-negative. Non-negative, since x minus 1 whole square always greater or equal to 0. Okay, in R, it implies 3 into x minus 1 whole square is also greater or equal to 0 in R. It implies f dash x, this value is what? This value is f dash x. So f dash x greater or equal to 0 in R. Okay, so fx is increasing in R. Okay, strictly increasing means greater than 0. Increasing means greater or equals to 0. Note. 19. The interval in which this function x square e to the power minus x is increasing. Which interval is interval of increasing? So interval of increasing and decreasing, we have to find first derivative. Okay. Suppose this function y given, then write y equals to x square e power minus x, differentiating with respect to x, y dash equals to, here by parts rule is applicable because there are two functions. So in differentiation by parts, first as it is derivative of e power minus x, e power minus x derivative minus e to the power minus x plus e power minus x as it is derivative of x square is 2x. Okay, now we can see x common and e power minus x common. So from here x minus x and from here plus 2. In fact minus is also can be taken common, minus e power minus x, x minus 2. This is y dash, and we want to find interval of increasing. Interval of increasing means f dash should be greater than 0, f dash or y dash whatever. So do one thing, put y dash 0. If y dash 0, then from here this factor will give you x value 0 and this factor x value 2, and this cannot be 0. E power minus x is always non-negative. So from here we got two critical points. Arrange these points on the number line. Number line. This is number line. Okay, 0 comma 2, 0 2, minus infinity plus infinity. Okay, now look, in this interval what is the sign, plus or minus? Try to check. This interval is greater than 2, all the x values greater than 2. Now select any value which is greater than 2 and put here. Suppose you are selecting x value 3 and you are putting in y dash, then what you will get? Minus 3 e power minus 3 and 3 minus 2. So finally this answer will be here negative. It is always positive e power and it is positive, so it means negative coming. So this is negative. This interval is negative, and because all the linear factors, all factors are linear, so alternate plus minus plus minus. If first is minus, this is plus and this is minus. Or else you can check again, put any value between 0 to 2, select one and put here, you will get positive sign. Okay, so any method you can apply. Now we can find out, we can make a table. 3 interval 4 interval sign of f dash. Okay, nature of fx, nature of fx. So first interval minus infinity comma 0 and then 0 comma 2 and then 2 comma infinity. First is negative, positive, negative. Negative means decreasing, positive means increasing, negative means decreasing. We want interval of increasing, so which interval is interval of increasing? 0 comma 2. It means option D is correct. So interval of increasing, interval of increasing, okay, 0 comma 2 answer. You can also write interval of decreasing. There are two intervals, minus infinity comma 0 and okay, intervals of okay.